Okay, so for this video, we're gonna go over some more solving exponential equations. So these ones look a little different than last time. If you remember from last week, you looked at problems where the bases were the same, and if they weren't, you made them the same. For example, like 2 to the x is equal to 4 to the x minus 1, right? And you would change the base, for example, so that on the right you'd have 2 squared. Oops. Okay, so we would have that. And then the bases became the same, so then you were able to cancel out, and we would be left with x equals, you would distribute that 2 to the x into the negative 1, so you got 2x minus 2. You would solve, so you'd move this 2x to their side, so you'd minus 2x, you'd have negative x equals negative 2. You would divide by negative 1, and you get x equals 2. Okay, so that was last week. You were able to make bases the same, right? Now, what we're looking at today is we're not going to be able to create same base, right? So when we can't create the same base, there's a few steps that we can do. Now, I kind of put these in my own words. So for example, like 9, base 9 and 14, you could replace 9 with 3 squared, but you can't replace 14 with some base 3. 3 to the first is 3, 3 to the second, right, is 9, 3 to the third is 27. So you can't get same base. So then when you can't make same base, this is what you have to do. What I like to say first is, and this is in my own words, so it's not, the technical way to say it, but I like to isolate the base with the variable exponent. So isolate that value. So we're going to do that first. Then we're going to work on the side that the variable is on. Then we're going to look at the base, the number that is under that variable exponent. We'll apply a log with that value to both sides, and then we solve for the unknown. So let's look at some of these. So for the first one, step 1 says isolate the base with the exponent. So what I mean by that is we want to isolate 6 raised to the x. Okay, it is isolated. What I mean by isolated is I don't want to see anything in front of that 6, anything behind this term, right? This is one term, so that term is isolated. Step 1's done. Step 2, look at the side the variable's on. Okay, so we're going to look at the left side. Step 3, look at the base. Look at that value under that x. So the base is 6, right? Apply log with that value. So we're saying apply log base 6, because it said look at the base is 6. Apply log with that base to both sides. So on both sides, I'm going to read it like this. I'm going to do log base 6 over here, writing it like this. Log base 6. So then log base 6 of 6 cancels, so we would have x equals log base 6 of 42. Okay, so your base and of are both numbers, so we can punch this into our calculator. This is a number, right? So you have to use your change of base formula. So some of you, when you hit the log button in your calculator, it just depends on the version, you'll have a blinking light or blinking box that's here and here, and you could just plug in the numbers into those spots. But for some calculators, if they're a little bit older, you have to do change of base. So I'm going to write down what will work for either calculator. So change of base means you do log in your calculator, no matter what calculator you have. You can do log of the quote-unquote of, so log 42 divided by the log of the quote-unquote of. Okay, so that's the change of base formula. Log 42 divided by log 6. When you just hit that log button, it assumes, like your calculator, if you just hit log button, it assumes that it's base 10, right? And base 10, you'll either see like log and then some number, and that you could just hit log button in your calculator, or it it has to say base 10 and then some other value. And that's when you can just hit log button. Otherwise, if this bottom number is something other than a 10, you need to use change of base formula. So log of 42 divided by log 6. So if I put that in my calculator, log 42, close parentheses, divided by log 6, I get about 2.08. So let's see. So x is, I'm approximating 2.09. Okay, so that'll be my answer. Okay, so let's look at the next one. So for the next one, I'm going to go back to the steps. So step 1 says isolate the base with the variable exponent. So here's our base, 3.1. We've isolated that quantity, meaning there's nothing in front or nothing behind that pink bubble that I just circled. So then step 2 says look at side variables on. The variable's on the left-hand side, so we're going to pretend we don't see the right. Look at the base. Our base is 3.1. Apply log with that base to both sides. So we're going to apply log base 3.1 to both sides. So I'm going to do log base 3.1. What do I do to the left? I have to do the right. Because this base and of are the same, do those log rows cancel? So we're left with a minus 3 is equal to, oh shoot, you guys are supposed to do that. Okay. No, I'll do it for you. Okay. You're supposed to do that one, but I'll do it. Okay, so it's log 9.42, base is 3.1. Okay, right here, this is a number. Okay, so I'm going to pop that in my calculator first. I'm going to do log of 9.42 divided by log 3.1. So log of 9.42 divided by log of 3.1 is about 1.98, right? When your base and of are both numbers, this is an expression, this is a value, this is a number, so it's 1.98. And then we're going to solve for a, so we add 3 to both sides. So a is approximately 4.98. Okay. So I'm supposed to just do the ones that say examples, and you guys are supposed to do the ones that are numbered. So you guys are going to do 1, 2, 3 on the right-hand side, 4, and 5, and I'm going to do the ones that say example. But when you hand this in, we want you to show work for all technically 10 of these things, showing the example work, meaning you watch these videos, and then you doing it on your own. Okay, so for this next one, step 1 says isolate the base. So this base e, it's e to the 2x, that's what we want to isolate. This is, think of it as 4 times this blue blob, right? 4 times. So you want to divide both sides by 4 first. That's step 1, isolate the base. So I'm going to write 1. So now we have e raised to the 2x is equal to 5 over 4. Okay, that's step 1, isolate. Step 2, look at the side that the variable is on. Okay, so again, we're looking at the left-hand side. It's the side that x is on, right? E, right, E, just like pi represents a number. E is approximately, right over here, E is approximately 2.718, right? But anyways, okay. So we're looking at the left-hand side. That's step 2. 3, look at the base. Apply log with that value to both sides. So we're looking at our base. Our base is E. E is a number, okay? You can replace it with 2.7 if you want, but leave it as E. So log base E on both sides So that would cancel. So we would have 2x is equal to log base e fraction, I'm going to put in parentheses, 5/4. Now, this is a number, right? So before I divide by 2, I'm going to evaluate and see what this number is. Now, there's 2 ways to put this in your calculator. You can do change of base, right? So you can do log, depends on what's easier for you, log of 5/4 divided by log of e. Now this e, on my calculator, you have to hit shift and then you hit the divided by button. You'll see it there. So if you hit that, you'll get a value. Or if you guys remember, log base e is natural log. So if you want to just replace log base e with ln, they're the same thing. So that might be a little bit faster. But some people just prefer working with logs. So if you just like always working with logs and not working with natural logs, just do log of the of, so log of 5/4 divided by log e, and then you're set. Okay, so whether you hit log 5/4 divided by log e or you hit ln 5/4, you'll get the same thing, as they are the same thing. So you'll get about 0.223 approximately. And then last step, we divide by 2. So we get about x is approximately 0.112. Okay, so this is video number 1 because it's about to cut off. So again, you're gonna watch the other videos, write down all the examples that I show you. I'm gonna show you 5, so I'm gonna show you 3 more, and you are going to do on your own the ones on the right. 1, 2, 3, 4, 5. So in theory, you are showing work for all 10 things, even though we're showing you 5, how to do 5 of them. And you're going to try the other 5, but you're just going to submit all of this as one document. Okay, next video we'll have the other 3.